Good morning. This is Jessica from CorpU, and I'd like to welcome you all to today's Smarter Growth webinar with Foster Provost, our partner from NYU. A few housekeeping items before we get started. All attendees are in listen-only mode, so should you have any issues or questions during the webinar, please type a question into the question box, and I will get back to you. Without further ado, I'd like to introduce you to CorpU's founder and CEO, Alan Todd. Alan?
Hello, everyone. Welcome to our Smarter Growth series. Today, we have a really great show prepared. So today, we're going to focus on developing data-savvy leaders, and let's talk about who's with us today and where we're going. So I'm really excited to have Foster Provost with us. Foster is the author of the book Data Science for Business. He's a professor of data science and information systems at the NYU Stern School. He's won many awards, and we've had a long-standing relationship here at CorpU with Foster, and we'll talk about that a little more. But Foster and his colleague, Vasant Dar, who edits the Big Data Journal, together developed a program that we put together that's a 6-week guided learning journey to help people make sense of big data analytics and harness that and work to help leaders to build the skills to work with data scientists to make sense of big data, to make better decisions, to drive innovation, so on. So we're really excited to have Foster with us today. And I just want to start by reminding you all why we're here. And we're here, and why do we exist at CorpU is because we aspire to build great leaders who make great contributions to society and to business. And that's why we are here. And we know that many think that leadership is in a crisis, and our goal at CorpU is to build the world's best, the premier leadership development platform, one that makes big impacts. And we know with the way we measure our Net Promoter Scores, with over 100,000 leaders that have been through CorpU programs with impacts that have been greater than over $1 billion in impact value created, that's been reported by our participants, people that go through programs. And it's important that we focus on problems that are in the real world. We chase down the best experts in the world. We design programs, make sure that they're expert-led, that they're rooted in a business challenge, and that people do them over time and working. And so as simple as all of our programs are 30 minutes a day, 3 hours a week, typically 3 weeks long or 6 weeks long. So the program on data science for leaders is a 6-week program. So you can think of it as 2 3-week chunks at about 3 hours a week. So people do this at work digitally at a distance. We tailor everything for each customer. And again, we've done this for many of the large global Fortune 500 type organizations. But let's talk about the need for data science before we get to Foster. I thought I'd point out this article was in the Chronicle of Higher Education earlier this week. And what I found fascinating is that Purdue is a great institution. And it's interesting that all of the faculty members are working on an initiative to permeate all educational programs with data science. And they quoted research in the Chronicle that 2.72 million new jobs require some data analysis and management skills. And so they called it their provost and executive vice president said this is the grand interdisciplinary challenge, is how do you extract new knowledge from big data? So I just thought it was a big deal. It sort of teased this up. And what my reflection on this is simply, if you think about building future leaders at the higher education level at a university like Purdue, and I suspect many others are doing the same thing, what is it we're doing with the fact that we have 50 times as many adults in the workplace who need these skills today to run your business tomorrow? So how does that happen? So one of the experts in the world of analytics, someone that has written a number of books, Tom Davenport, published a book last year that just described where we are in analytics. And essentially, if you look to the far right, we're at the point where we're trying to remove humans from the equation. And Foster's going to talk a little bit about that today, but you hear terms like AI and big data, blockchain and cryptography, and we're going to try and see if Foster can help us make sense of all of those things. And it's important to think about, how do you make decisions? How do you develop people that can apply good data-based or evidence-based data into making decisions. And what we know is that people, they understand that that decisions should be rooted in evidence and evidence-based practices, but in practice, they very often struggle to do that. And so we think there's a huge need, and culturally, a lot of companies still have a culture where people use gut instinct rather than data. And so we know that it's a tough road to hoe, but one that is certainly worth working coming out the other side. For those of us that work in the world of HR and talent, the Society for Human Resource Management, SHRM, has been studying this topic and says that the HR world is falling short, falling behind. And so from the HR perspective, we've got to pick it up. We've got to use this to measure employee engagement and make predictive and prescriptive directions to improve leaders' ability to gain insight from data, to solve problems, to make better decisions, to engage employees. And so we know that that's got to happen. And if companies get this right, we know that those companies tend to be at the top of their industry. So they're more productive, they're more profitable, they're driving industries. We know that companies that struggle to get this right, I mentioned cultural issues are one of the big barriers in getting this done. And another big barrier is even if executives could figure out what they're supposed to collect, they don't know how to analyze the data once they collect it. So they're not really aligned with where do I begin? And if I did begin down this path, what do I do with it once I have that data? And so with that, I'm going to tee it up, turn it over to Foster. And Foster, if we could, while we're passing the baton over to you, we just talk about where do we start before we get into the presentation? Like what do people do to make sense of all the things I just teed up?
Yeah, thanks, Alan. Let me just click my button here to switch over, and then I'll respond. So yeah, I mean, this is actually the number one question that I get from business leaders. I spend a lot of time talking to people in a wide variety of different firms, from small to huge. And right now, really, the main question seems to be, how do I get past the hype that I read in the popular press and I hear in the in my industry, the bluster of vendors, the opaque details from the technical press and the technical work, and really understand how we can get business value from our data, and use this stuff that seems to be useful, but I don't quite really understand it. And if we dig a little deeper into concerns like these, to me, two things become clear. First, there's just a lot of different things going on. And so it's hard to understand because there's a whole bunch of different things under the hood. There's the choice of what problem should I address. There's a choice of what technologies should I use. There's a choice of, which you mentioned before, of what data do I need to collect and bring to bear. There's a choice of whether do I address individual problems or whether I should be working on building a platform for my whatever, data science, AI, whatever we want to call it. There's how do I build a data science team to be able to actually realize the value. What is data science really anyway? How do I structure my overall data analytics or AI efforts so as to get the best chance of success? And these are all vital, important questions. And if we don't disentangle them, we're never going to be able to talk clearly about them, let alone to come up with a plan for what to do. And so I guess my first piece of advice is just take your time. That's a lot of stuff. There's not a simple answer to it, but it's also not something that a business leader isn't going to be able to understand. We just have to basically systematically disentangle things and then look at the pieces. And then I think the second part of the answer is what was right for some other firm probably isn't exactly the right answer for you. So you should be thinking about things in the context of your own business and your own problems and your own strategy and capability and challenges and opportunities and resources. And what I like to do is to think through frameworks that help us think about this in our own context.
So Foster, can you just connect some of those questions? You asked a bunch of really good questions about what problem, what technology, what data. Can you talk a little bit, just connect for our audience, the big data course that you put together, the guided learning journey, and talk just a little bit about how that connects to helping companies to answer these questions?
Yeah. So what we try to do is to get the the students in the course, the business leaders and students in the course, to really start using some of the basic frameworks for. I sort of think of them as frameworks for data analytics thinking, right? How do I think about my problems? It's not a course about technology. It's not a course about algorithms, really. It's about fundamental principles, and then how do I start thinking through applying these technologies to my problems. And yeah, and today we'll get a little peek at that.
Yeah, so we're interested. Tell us more. What do you have in store for us today?
Yeah, so the rest of this morning, I will give an introduction. It's just an introduction. We can't, obviously, in the time that we have, go deeply into the stuff, but an introduction into what I think of as three of the most important frameworks for discussing some of these questions. I was a practicing data scientist in the 90s for 5 years, and I've been working on advising lots and lots of companies over the course of my career. And these are frameworks that I still use, even though I have my own intuitions and everything now. I still use these frameworks in my own data science and analytics practice to help me systematically take a complicated, sort of business problem snowflake and divide it up into manageable pieces that my limited little mind can actually, work with. So that's going to be what we'll do today. We'll
beautiful.
Whenever we're ready, we can start.
Rock on. It's all you.
All right.
Thank you, Foster.
All right. So, and you can see my slides now.
Perfectly.
Okay, great. So, the conventional view to start thinking through what can I do with data analytics and data science and AI technology is to get a list of all the different kinds of problems that might be solved, like attrition management or targeting offers, ads, promotions, recommendations, the Salesforce allocations, inventory supply chain management, fraud control, credit for payment default, and so on and so forth. Right? And this is a really useful way of helping yourself think, what problems might I have? I actually don't think it's the most useful for then figuring out what I'm going to do. I like to start with a different framework, and that's a framework that's thinking through what kind of things do I want to do as a business. And so I break that up into 4 categories. I may need to explore. Use my data to explore, and maybe I'll discover something. So an example of this would be actually, let's use one of our examples. I'll take the top one, attrition management. So maybe I need to explore and find out, do I even have attrition problems? Maybe there's a subgroup of my customer base that we're not serving as well as we might serve. So that would be in the exploration and discovery. If I can move on just across the top here from left to right, the next one would be understanding. Oh, maybe I found out, or I may not have found this out through exploration and discovery using data science. I may just know it from other reasons. I seem to have an attrition problem. Can I understand what really is my attrition problem? And probably I want to dig down and try to get a causal answer. What is causing my attrition problem? Right? This is a different sort of task that I want to solve. And it turns out that each of these categories of tasks is solved using possibly some of the same algorithms, but very different methodologies. So let's just say now I've understood, I've noticed I have an attrition problem. I've understood some of the reasons why. I design an intervention that I'm hoping will stem the attrition. Now I have what I would call an optimization problem. And I use optimization very broadly, not in some mathematical optimization, just we want to do better than we were doing before. This could be reducing costs in some applications. It could be increasing profits. So here we want to do better. We want to not be losing so many profitable customers, right? And so how do we go about, like, a question you might answer there, which I'll dig in a little deeper through the rest of the morning, is, okay, now to whom should I offer this offer, given that the offer is going to be costly, especially if you're talking about attrition. Sometimes you actually can wake a sleeping dog if you offer the offer to the wrong person and then increase their likelihood of leaving, right? So that's the third category. And then the fourth category is, remember I mentioned very early about this question about, do I want to build a platform or do I want to right now go and solve some problem? This is an important question, and actually we can separate that. When we're building a platform, we're creating ourselves an option, right? And so we're willing to invest when we create options, and so we should be thinking about it in those terms. And so I think those are four very different things that firms want to do, and this could be even within this one category of attrition management. Then at a much lower level, so that's sort of high level what we want to do it as a business, and at a lower level, there's some things we need to be able to do. If we're going to be able to do any of those things by using our data, we need to be able to find out facts, produce summarizations, maybe produce visualizations, maybe test hypotheses, and maybe engineer data. And so this is not really what our course is focusing on, but but this is important stuff. And so if you can't if your data aren't in databases from which you can now start to get the data out and find the facts and summaries, it's going to be very hard to do some of the higher level things. And then in between there are these technologies that we are calling these days advanced data analytics, with data science underlying them. AI is the hype buzz term right now, and I'll try to disentangle that a little bit in a little while. Machine learning, likewise. And so here is where we're going to try to bring to bear some advanced machinery to help us do the things above. Okay, so we've been doing essentially drawing inferences from data, for a long time, and for many problems we've been doing this manually. Increasingly, especially over the last 10 years, these have been more and more automated, but still we have situations where there is some knowledge worker. The knowledge worker looks at some data and then does something, makes a decision, or gains some insight that's going to improve the performance down the line. But there are certain reasons why you don't. Oh, I have an example here. So you have Acme Plumbing. Is Acme Plumbing a potential small business customer? Yes, she says, right? And so let's allocate a salesperson, or probably not. Let's not allocate a salesperson, right? So this isn't such a great approach for many decisions. Usually, either because the knowledge worker does not really have sufficient knowledge, and a data oriented algorithmic solution can actually do a better job of making the decisions. And by the way, I'm not going to talk about it today, but very often what we really want to do is to integrate the humans and the data to do better than either of them alone, right? And the other reason is the knowledge worker simply can't process enough cases because humans have quite a limitation. And so if I'm the phone company and I have 500 million customers, no one's going to be able to actually go and try to estimate the likelihood of attrition for the different customers, right? So in these cases, we tend to be increasingly building AI solutions, and we're seeing this across all of those problems that I listed up front. Some of the earliest ones that we had AI solutions were for fraud detection. I worked a lot in fraud detection. I'm still amazed at just how fast I get an alert that something weird is happening on one of my accounts. Same with attrition, with targeted offers. What's going on under the hood in the online advertising system is sort of pure AI. And so here we have an algorithmic solution, and we can through as many customers as we want. And I'm going to right now, I'll unpack this in a little bit. Let's just say the system is making a decision, target or don't target with whatever the incentive offer that we've designed in is. Now I made a little note here. AI systems also sometimes incorporate even more complicated things like search, planning, and so on. And so I was an AI graduate student back in the 80s, and the idea that you could have a system where I said I would like to get from here to there, and it would plan a route taking into account traffic and one-way streets and everything, was pure science fiction. That was AI. And now we do that every single day, all the time, right? And so this is, I mean, so the AI has been, even though there are hype cycles, it's been just slowly infiltrating more and more things. I'm not going to talk about the search and the planning today, but I just wanted to point out there's more things besides just knowledge and inference. And I'm going to be talking most mainly about knowledge, inference, and machine learning in a second. Okay, so let's now unpack this a little more. The AI system really doesn't look like that. It's a computer system, and it's usually a component of a computer system. And so you have this question: will the customer leave? The customer is described by some data, and then inside the AI system is knowledge for estimating attrition likelihood. And so the next stage would be some estimated probability distribution over outcomes, and then that's going to go into a subsequent decision-making process, either human or another stage of the computer system. And where the data science generally tends to come in is answering the question: where does that knowledge come from? Where does this knowledge for estimating attrition likelihood? And there's two main answers, and usually a combination of the two, but two main answers. One is it comes from humans, from a combination of data scientists, engineers, experts, and they work together to program a system that can estimate the likelihood of attrition based upon their knowledge. And so I say that's part one. And back in the 80s, by and large, the AI systems that were built during the first AI hype boom were done this way. People were called knowledge engineers, and they built systems. And despite the fact that there was a boom and bust of AI, a lot of important business systems were automated. Like I mentioned, there was fraud detection, and there's a lot of operation support systems were built just like this. Now we're seeing essentially what we're calling machine learning as helping to build these systems as well. And so we're also now in part two, we're estimating this in our example here for customer attrition. We're estimating attrition likelihood from data. Okay, so that was really the first framework, is think about this high level. What are we trying to do? And then I am going to be digging down into this optimization bucket, but we could have dug down into any of the other ones, into the optimization area, and basically saying, okay, we're going to want to, in our particular instance, one of the things we want to do is to estimate the likelihood across all our customers of their attriting, so to speak. And then we have things that we're going to do about it, right? So a second framework that I find to be very useful is a process model of how we go about building AI and machine learning and other data science oriented systems. For my students, I have them when they put together proposals, they use this as a framework for putting together proposals. When I have them analyzing proposals, they use this as a framework for helping analyze proposals. When they do their projects, they use this to help think through projects. And the same goes out in industry when people are walking through and getting themselves in order to do AI and machine learning systems. They use a process, maybe not this exact one, but something very similar to this, right? And so one of the key things about the process is it starts up here in the upper left, and it starts with business understanding, right? And data scientists don't necessarily naturally do this. Data scientists often, what they'll do is they'll just start to think about algorithmic things. And this leads to what we kind of jokingly call type 3 errors. You might have heard in statistics about type 1 and type 2 errors. I'm not going to talk about that right now. The type 3 errors are building a really accurate solution to the wrong problem. And so the business leaders who are going to be implementing solutions like these in their business really have to be involved early on to make sure that the right problem is being solved. And this actually takes some work. Very often what you're doing is you're peeking back into how, if a good solution were to be built, how would it be deployed? And so you work on this. And so we talk, when we dig deeper into business understanding, we've got some frameworks to help us think through business understanding, right? And then we see there's this little mini loop between business understanding and data understanding, because we're going to then go, and I'll give a framework to work on this in a second, that's going to be our third framework, but then we're going to go and try to understand what are the right data in order to help us solve this problem. And it's a little loop, because sometimes as you're understanding the data, you rethink what really is the business problem. And as you rethink the business problem, you rethink the data that you're going to use. And at some point, you get to the point where you're like, okay, enough thinking, we want to do, and then you move on. And then there's usually a significant effort in preparing the data to be able to mine it or do the machine learning necessary to build the AI system, right? And from there, we move on to modeling some phenomenon. And modeling, again, is a very broad term. It's essentially finding from the data the knowledge that's going to be useful to help us solve the problem. And again, while you're doing that, very often there's a mini cycle where you go back and you change the way the data are prepared. At some point, you think you have something good, and you're going to go to evaluation. This is extremely key in doing machine learning and data science, because essentially you don't want to deploy something without a kind of an in vitro assessment of how good it seems to be. And you'll see the process model has a line back to the beginning, because this is usually an extremely high uncertainty process about what you're gonna do. And so very often when you evaluate things, you figure that it's not working exactly the way you want it to work, and you go back to the drawing board, because by that time you actually understand things much better. You revise your business understanding, and then you loop again. At some point, you, if you're lucky, you have a system that you're willing to now deploy. You deploy it, hopefully you get some value for the business, and then there is this overall loop, because often now that you've gotten to that point, you really understand things better, and you say, if I were to do that again, I would do it completely differently. And so you go back, and you can either decide, is it worth the investment to now try again and make it even better, or did going through this reveal some new problems now, or I started to build my data platform, so now I can do things that I couldn't do before, and so on. So this is a process that that we go through, and my real advice is don't leave it to the data scientists. You have to understand the basics of this as the business stakeholder. Otherwise, it's not going to work. It's going to work purely because you happen to have some data scientist who happens to have a lot of business acumen.
Hey, Foster.
So, yes.
Yeah, a question about your model came in, and the question is, how often does it occur? You called them type 3 errors, and do you know what the barriers or challenges are that keep people from following a process like the one you're showing?
That's a great answer. So the first part was, why do they occur, or how frequently do they occur?
How often, is this, yeah. So you're presenting a model, and the question is, how often is it the case? So we know that there are a lot of failures, and there are a lot of, I guess, type 3 errors. And I'm wondering, in your experience, as you deal with executive education environments and customers, right. Do you have any sense of why people can't why they aren't? Is it a cultural thing? Is it why is this prevalent that they don't follow a model like this, and they end up with type 3 errors?
I think it's generally just lack of understanding of good practices here. Things are changing. I actually believe that, and we're going to get to this in a minute, but I'll foreshadow a little now. I believe that the best data science-oriented companies are now minimizing the type 3 errors. I think the places where the type 3 errors are the largest are either where the firm just decides it's going to do it kind of ad hoc. And so they just don't even know enough to follow a process, And the other is where you just hire data scientists. The data scientists who knows where they come from? They may come from computer science. I come from a computer science background. But the students coming straight out of computer science don't necessarily know a lot about business. Right. And so they don't necessarily know what's necessary to get the problem formulation right in the first place. So I think a lot of it is just an education issue. I hope my students because we spend lots of time on this. I hope my students are minimizing their type 3 errors. I also think that there's just super high uncertainty. So what I'll get to as kind of like the last piece of today is there's also issues about how we structure our investments, because I think type 3 errors are inevitable because we just at the beginning very often just don't understand enough. And so I think there's ways to minimize the loss from type 3 errors rather than just minimizing the type 3 errors. So let me get to that in a little bit.
Great, thanks.
Right. So going through the process just as an example, right? Our first question is going to be, what exactly is our goal, right? And so I do a lot of workshops here with business leaders who want to sort of think about how to apply this. And so the first thing we do is not this. The first thing we do is try to think through what would even be a good problem to address with that first framework. But once we've picked that, often it's an optimization-oriented problem, and so now we have to dig in and ask what exactly is our goal. So let's just say that in our example, we want to either minimize attrition or maximize our revenue by somehow minimizing the loss due to attrition, right? And so to do this, we need to understand the costs and the benefits in the decision problem. I'm just going to give examples of things that we're going to do, not try to solve the whole problem here. In data understanding, we're going to need to do what quantity are we going to look to be able to estimate? Very often when we're using data science in an optimization context, there is some value that if we were to know it, we could do better. Like, will these customers leave? Of course, you don't know that. You might know it after the fact. And of course, it's too late then, right? But if we could predict the likelihood of leaving, then we can use that in optimizing our intervention strategy. So we usually call that a target variable. And so a lot of the first thing generally we would want to do in here is to get in there and just make sure everyone is on board with what is going to be the right target variable. And sometimes there's multiple target variables. And so a lot of type 3 errors come from, it was a poorly specified target variable because you didn't go through that careful thinking. And then you went on and you modeled it and you evaluated it. And if you have the wrong target variable, you evaluate it, it looks like you're doing well because you're getting the right, again, a very accurate answer for the wrong thing. Then what data would we be able to use to make these predictions? Again, this is one of the places where the creativity and business knowledge of the business side really comes to bear, because the data scientists will gather what data happen to be available. But often the data that really make a difference are data that get engineered based on someone's creative idea. So in attrition, at some point, a business person said, guess what? Maybe if people's friends are leaving, that might be very predictive whether you're going to leave. And it turned out that's not something that's in the data, but after some creative people figured out how you might be able to measure this, like in telecommunications churn, you can look and see who calls whom, and then look at the attrition rates or whether or not there has been attrition on the people that people call very often. It turned out that that was the most predictive variable. Right? And it wasn't there initially. So this is a case where the data understanding and data preparation, you've engineered some data that will end up being helpful in optimizing our attrition problem. Right? And we could go on. What I want to do, because we only have so much time, is to make a distinction that I think is very muddled in the popular press and even in some of the literature for the business side of things. And I even think when the technical people talk about it, they don't really draw out this distinction, but it's important. There's actually two different data analytic processes going on when we are building these AI systems. The first one is what we've been talking about so far. I'm going to call that the model in use. So you have some knowledge. You have an instance of the thing that we want to optimize for. Like, for instance, this might be an instance of a customer described by the customer's data. The knowledge then is going to do what we talked about before. estimate the probability of attrition. This is an AI system or a data analytics system, depending on what year you're in. We would call it something different, but it's essentially using knowledge for inference, and it's what we've just been talking about. It's not machine learning. There's no machine learning going on there at all. Machine learning is a different process. Machine learning says, what if I had a whole bunch of historical data on customers, some of whom have left us and some of whom have stayed? This is what we call labeled data in the jargon of machine learning, right? The idea there is they have this target value specified. If we can get data that have the target value specified, we put it into a machine learning algorithm, and the machine learning algorithm's job is to come up with a model that can predict who's going to leave and who's not going to leave, right? So the difference is that they're both computer programs, but one takes an individual instance as input for which we don't know whether they're going to leave or not, and estimates whether they're going to leave. And the machine learning takes a bunch of cases where we do know whether they left or not and builds a model or knowledge about how to estimate whether somebody's going to leave. And of course, the link between the two is this model can then be used in the process below. And for these very modern systems that actually, so let me back up for a second. I got one sentence ahead of myself. This, generally speaking, this dotted line here has a lot of human curation involved. You build the model, and then there's a lot of work to just make sure that evaluation that we talked about, getting it deployed, putting it into deployment, the managers who have to sign off on the deployment, people want to understand what the model's doing, and so on before it actually goes in and starts being used in production. The most sophisticated AI systems now have a loop, because now the model goes into production. Then we see now, we predict whether somebody's going to leave. In certain cases, we then later on will have the truth revealed to us. Did they leave or did they not leave? And now we can loop back, and that becomes more labeled training data, and now our cycle can iterate. If we can automate this dotted line, which is where they're putting the model into production, which is the real sophisticated, most recent AI systems are doing, now the system actually learns as it goes on. There's still these two different data analytic processes. They're just connected now in a tight loop. And so when we're talking about AI systems, we might just be talking about this bottom level. If we're talking about AI systems with machine learning, we might be talking about machine learning and AI system as two different things with human curation and deployment in between. And then we might also be talking about systems that actually learn from their own behavior as they go on and on, as they're used. So I've gone on. And so to me, again, this is just what we just summarizing what we said before. What makes the biggest difference in the success of these systems is the problem formulation and the engineered data. And I'm not going to reiterate because I talked about that a bunch already. My kind of, maybe this is getting into the last thing that I wanted to talk about is, and I foreshadowed it before, is there are also issues about how to structure projects, structure efforts. The efforts may be multiple project efforts, but generally to structure efforts, right? And so a case that gets used a lot in business school classes now on sort of using data science and AI is this unfortunate for both the customer and for IBM case where IBM Watson was building systems and was sort of doing a lot of advertising about its work with the healthcare provider MD Anderson, and then it was basically revealed that the project failed. Look, projects fail. The striking thing is that MD Anderson essentially spent $62 million, and the project didn't meet its goals. And if you're interested in this, there's a MIT Technology Review article that does the post-mortem of it, and it looks like, I mean, it's easy to be a Monday morning quarterback, but it looks like it's stuff that should have been caught very early. Maybe before you spent whatever 2% of the 62 million, you at least could have possibly seen that you're going to run into these sorts of problems. And so, so one of the things that I try to instill in my students, and that we work very hard on when we're working out in industry, is to think about how to invest in data analytics and machine learning on an effort by effort basis. And so what I basically have here is this idea that, remember, in our cycle we had this outer cycle, right? And I have this spiral, and the idea would be, it's actually very similar to, if you know about software developed to an agile methodology. There's differences, but I think that's the best analogy, where you start early on with a very small investment because it's a super high uncertainty project. And so you do very quick proof of concepts and pilot studies to help you to understand better. And then as you understand better, then you might, if we think about the size of the spiral as the amount of investment, you might decide that now we're going to increase our investment. In order to do a quick pilot, we made lots and lots of approximations, and so now let's relax some of those and go on. And so we will have a lot more information about feasibility and about exactly what we want to do before we make a very large investment. So that's pretty much the three frameworks in a whirlwind tour. The first one was thinking through the types of questions that we're going to want to answer, and there are different types of questions even within a single application. The idea of that there is a way to progress through the process that minimizes the chances of these type 3 errors, and this idea that we need to disentangle the different data analytic processes if we're going to want to be able to build the things that we want to build, and also I think to understand what people are talking about. Right, and again, I don't have to repeat this over and over again. The most important thing is to ensure that you got the business understanding and problem formulation correct. So I think that's a good place to stop. I just put a couple other areas of attention. What's the right problem to work on in the first place, which I mentioned? How do you build a team to work on it? How do you structure the projects to minimize risk, which I talked a little bit about? These are really sort of for kind of other lectures rather than this one. So thank you.
All right, perfect. That sounds like a great break point. So if you have any questions, type them into the box at this time. Somewhere in that GoToMeeting gives you a chance to write some questions. We have some questions coming in. So I want to ask a question first, Foster, about the three frameworks. How do people get started once you to sort of put those into action? Is there any, like, what does day one look like, and how do we, with our course that we deliver, tailor in such a way, like, to help people get started? Is there a way to get basically, how do you do it? And when you talk about the team, like, what would be the sort of the optimal team for you in terms of business leaders, data scientists, IT people? What would that look like, the optimal team to get something done, to grapple with the three frameworks and actually come to resolution on something to do?
Yeah, great question. So then I think there's really two questions there. One is what's the right team structure, which I'll get to that with second, and the other part of the question is how should we really get started? My view is the problems that actually are the most straightforward are the optimization problems. And so if you can look at the challenges or opportunities that you currently know that you have in your business, try to think of which ones are cases where I just have a gut feeling that I can do better with data, and pick one where you think, if I were to be able to optimize something, and I'll get to that in a minute, I would add value, right? And the list that I put up at the beginning, which I think you can find those kinds of lists online, but we'll be happy to provide a list like that of the kind of things that people currently are doing with data science and machine learning, I think helps to pick. And then the framework really, the framework here really says, well, this says work on the business understanding. We talked about, can you define a target variable? Can you define this quantity that I don't know, and if I were to know it, I could do better. Right? And so there's a little bit of an art to doing that. But once we've defined it clearly and precisely like this, it's actually not that hard for the business people to do. You can do this without having a data science team. And so I think this is where we really want to start. And what does our course do? Our course actually does exactly that. It tries to clarify these concepts and get people thinking about, do I have a business problem? If I have this business problem that I want to do something better, is there this thing that I might want to be able to estimate, whether a customer will leave or not, whether a customer will respond to an offer, whether a recommendation will be taken, whether there's fraud on an account, whether a customer will default on their credit, right? These are all the instances of the target variable, right? And then start to think about what data might be useful to predict that. That you can get going there without having the data scientists, just by having like a data science for business 101 understanding of just the basic concepts, which any business person can get. Then the second part of the question was, what's the optimal team? That's a really hard question, but generally speaking, there's a lot of effort done in data preparation. So you want to have essentially engineers who are going to know enough about data science to be able to, when you ask them, can you get me this data? They actually get you kind of the right data in the right format, engineered in the right way. And then usually you need some people who are going to be able to run the modeling exercises. How do I build? This doesn't have to be a PhD with 10 years of experience, as long as you have the business side involved, right? So that they can address whether or not you're actually solving the right problem. And now you can go through that, get started going through that loop. I think the most sophisticated firms also then will get someone who is going to act in the role of chief science officer, is going to help to pick the problems, help to nurture the team, to keep, figure out what is it that makes data scientists happy, because they have a lot of opportunities. I don't want now attrition in my data science, team, and so on. So I think then there's a lot of future issues with basically building and nurturing data science teams.
Okay, so let's pick up talking about the skills and the team. I'm wondering if you have any thoughts or any. It's kind of a complicated two-part question here. Is how much technology do business leaders need to build, and how much business skills do data scientists need to build? So if we were thinking about, so we have a lot of HR, talent development, learning leaders on our call today, and so they're thinking they're charged with talent development. So as they think about developing stronger business leaders, how much tech, big data, and as you're thinking about IT skills and upskilling your IT workforce, do you have any sense about how to get the IT people a bit more business smart, how to get the business leaders more data savvy?
So getting the business leaders more data savvy is really been my main focus for the last 20 years. So I can speak more to that.
Please.
And what I've been, for instance, I teach the MBA students. I teach the intro class for our Masters of Science in Business Analytics, which is really a business set of business people who are now learning something about the analytics. There I have come up with what I believe to be the things you need to know about analytics. And we don't have a prerequisite for our MBA course. Every single person who can get an MBA, everyone who has an undergrad, we also have undergrad version of it. It's the same concept, can all get in there and have essentially it's a one semester class where I believe you come out and you learn the things that a business person needs to know in order to be able to be on the business side of these kinds of projects. If you're not going to come to Stern, or if you're not going to take the CorpU class, right? There is the book that I've written. I think actually that the book is one resource. I actually think the CorpU class is another one, and what I'm hoping that we're doing is at CorpU, then we will build follow-on classes And then after you've taken the first one, you're going to really want to take a bunch of other follow-ons where the follow-ons are not technically oriented. They're really oriented to get the business people to know what they need to know. On the technical side, I do teach the technical people to learn about the data science concepts, and it ends up actually being the same concepts that I teach the business leaders, because the technical people know lots and lots about the algorithm. Well, actually, engineers don't even necessarily know about the data mining algorithms and the data science algorithms, but they still need to know about this interface between the business and the data science. Getting the business, the tech people to just basically generally learn more about business, that's kind of outside my sphere. I guess that's when they come to business school to get their MBA.
Right.
I'll leave that to some other professor to figure out. If it's not focused on the data analytics part, on the rest of business, I guess you can get the like learn MBA stuff at home book or something like that. I'm not an expert in that.
Yep. No worries. I think your book is focused on data science for business leaders. The program we developed together is focused on the business leader side of that. One thing that we're getting a lot of questions about, and I wonder if you could connect dots for people, and these are just other buzzwords that aren't big data: blockchain, cryptocurrencies, ICOs. Like, how do you think about the world? What's going on in your universe with regards to big data and its relationship to blockchain, crypto, and et cetera?
Yeah. So
AI.
my view, I am with the participants who answer those questions, because even as academics, I don't know that academics like to admit things like this. Even as academics, we're still trying to figure out what the heck's going on in that space. In my department here, I've got some experts in those kind of things, and we could, if it were worthwhile, we could go and push further on that. But to me, these are two separate areas: the crypto area and the big data and data analytics area. The blockchain. The blockchain is a distributed ledger, and there's a bunch of things that it does, and there's articles by, if you really want to go and dig in, look for articles by Hannah Halliburta. She's from the Royal Bank of Canada, and she's been visiting here. I've been talking a lot to her, and she was really a clear thinker on this. And some of her articles, they're not super technical. She's really done a nice job of making them non-technical, right? And so the question is, in what cases do you need to have essentially a big distributed database that's kind of open to everyone, it's not necessarily anything data analytic there at all. There is a question then of, if you have blockchain, crypto, how could the two things be used together? I don't really think we have much to say there yet, despite the fact that people will talk. I don't really think there's much useful being said there yet. We haven't quite figured out what really are going to be the applications for which we really need blockchain. Everyone's essentially building themselves real options by getting into blockchain, because nobody knows yet what it's going to be really useful besides maybe Bitcoin. And so people don't want to be left out, and so people are making investments. And my view right there is these are basically buying real options.
Yep, got it. So Foster, today's the day for multi-part questions. So I have another one coming in. It's a triple. So do organizations struggle to clean up their data and prepare it for effective decision making? Does that take months or years? And how can they make progress faster?
Yes, the answer is yes, absolutely. The dirty secret of data analytics is just the amount of time it takes to get the data prepared. I think the answer to the other parts of the question, I will go quickly back. The answer to the other part of the question is really how good is the data architecture that the firm has already. And this varies as far as the spectrum is as wide as you can believe. I've been to financial firms that are sort of very old school and have very little that's actually there in modern, sort of data management systems, right? You go to, at the other end of the spectrums, you have Amazon and Google, where everything is really pretty much set up to be able to do this. And so the cleaning and engineering of the data in the first case is, yeah, you have to do everything, right? You have to build the databases often. You have to decide, do I need a big data architecture because but blah, blah, blah. We haven't talked about that. At the other end of the spectrum is, yeah, the data are all there. The engineering that we pretty much need to do is to, well, the data that we have aren't really the target variable that we would want. And so let's get in there and actually build a new data item that is the target variable that we really want. We don't have whether or not a person's friends actually are leaving. Okay, get in there and figure out how to actually engineer that new feature and then just put it into the database, right? And so does it take days or weeks or months or years? Again, it really depends upon what is the sophistication of the data systems that the firm already has. It can take years. What my view would be, that's probably not the project for which the data cleaning and engineering is going to take years, probably isn't the first project to work on. Work on a project where you think you're going to have a quicker win, and you start to build your platform, get your systems in order in the context of building a solution to a problem. I think some of the projects that have the highest loss from failure are kind of like the big engineering projects. We're going to get all our data in order, spend 2 years getting our data in order, and then we'll be able to solve some problems, right? Those are problems that have a high failure rate because it's not even clear what you're cleaning the data for, at the beginning. And so my advice, I'm not necessarily, other people may disagree with this. My advice generally is build the platform in the context of trying to solve some problems where you can get quicker wins.
Yep, I like that. Easiest problems. You talked about optimization problems. Use 3 frameworks. Get a team mixed together. Foster, this has been great. We have far too many questions that we're going to be able to get through at this point. But I will say, just to make an announcement, we are running I'm just sort of flashing up the 6-week program that people use, but we do have some open programs. And again, these are open for all CorpU customers at no charge, and there's a 1-week program for big data analytics taught by you and Vasant, and that comes May 30th through June 6th. We're also doing some supply chain, managing supply chain risk with Penn State, and make better leaders or better negotiators. Hal Movius from the Consensus Building Institute has a new book out called Resolve in our negotiation program, and we have a webinar next month with Hal Movius on the Making Leaders Better Negotiators. So next month is a webinar followed by an open program. But Foster, thank you again for your time today. We're looking forward to getting some of these folks, if they want to try out a little bit of our big data course. This 1-week open program is great for companies to send somewhere between 1 to 3 people. Send a team. I mean, ideally, maybe a couple business leaders, a couple data folks, and get them together. Ideally, those open programs, we tend to have about 30 to 50 people in them, and they're mixed up with about 10 to 15 different companies. So it's a great way to share best practices and figure out where you're all struggling together. And we'll be doing it through teaching some of the frameworks that you came up, that you taught us today. So everyone, thank you so much for your time. We're at the top of the hour. Foster Provost, it's been great having you on today. I'll see you Monday or Tuesday or next week at the CorpU Customer Advisory Board meeting at the University of Pennsylvania Museum of Anthropology and Archaeology. So that's next week, Tuesday and Wednesday for CorpU customers that are on. We'll look forward to seeing you all there. Thank you, everyone, and have a great day.
Yeah, thanks, everyone.
Thank you.